Hey everyone, this will be a video on 5.1. So majority of this section will be about graphing linear inequalities in two variables. I would highly suggest using Desmos for this, and we will practice with that in the video. You could do this without Desmos, but as we are graphing like 3 lines, 4 lines, 5 lines in some cases, and also in the future sections, it can be very cumbersome to have to do this by hand. Okay, so first let's think of some terminology here. So graphing inequalities is similar to graphing equations, right? So you can think instead of graphing y equals 3x plus 2, we might have to graph y is greater than 3x plus 2. How do these two compare? Okay, so you'll notice that when we're graphing a line, as in the first thing here, the line is kind of highlighting all the solutions that make this equation work. Now, when we graph an inequality, we're going to have an infinite number of solutions that will work. So typically a line will split the grid coordinate axis into two pieces. Typically they're called half planes, as you see down here, and you have your boundary line. So technically the boundary line is similar to the first one here, and then I'll shade either on one side of the line or the other. Okay, so for a vertical line, you either shade on the left or the right. If you have a non-vertical line, you're either shade like above the line or below the line. Okay, so for this first part here, it wants you to find the half planes determined by the linear equation. So we'll see down here that if you were just to graph this, right? If you wanted to graph this by hand, you need to solve for y. So we just add x to both sides. So we get y equals x minus 2. So then we know that the slope is 1, the y-intercept, excuse me, is minus 2. So we could graph this, and you'll see that that is done perfectly here. So I'm going to zoom in a bit. So we see we have this is that x minus 2 line. So you'll notice you have the upper part and the lower part. How can you relate this to an equation that's in slope-intercept form? So if we change this to y is greater than x minus 2, it is saying any y value that's above your line, you can think of it that way, which would be on the upper half. So then I would be shading everything up here. And one thing to note, since I'm greater than, my line would be dashed if that's what I'm going to do. Okay. You only color in your line if it is like this. Okay. This would be dashed. This would be a solid line. Okay. And in my lab, there is 2 indications of that. So your answer, let's say for this one, would be something like this. Okay. And then if you had the second one here, greater than or equal to, 1 and 2 look very similar. 1 has a dashed line, 2 would have a solid line. And we can look at the difference of those in Desmos. Okay. So for instance, let's just say I type in the first thing in Desmos. Let's go to Desmos. Let's reset our window with the home button there. And let's type in y. We see we have our inequalities here in the thing. Remember, if you don't see it, hit the keyboard button here on the left side to open that up. Let's say I do greater than or equal to x minus 2. And we see that that line is solid. Okay. Now let's say I change this to just be greater than, so I delete that. And what happens now? That line is dashed. Okay. So you always need your boundary line, and if it's greater than or less than, it's going to be a dashed boundary line. If it's greater than or equal to or less than or equal to, it's going to be a solid boundary line. You want to remember that. Okay. So the blue region corresponds to this, and that's because if you test any point that you could pick at the bottom here, it would be true. Okay, so any value I pick, like for instance, if I pick this point here, which is 0, -4, if I plug that in here, I get -4 is less than 0 minus 2. This would be -4 is less than -2. This is true. But then other points would work as well, and you can try as many as you want. Okay, so I'm going to zoom out a bit. Now, one thing I want to note is, suppose instead of writing it this way, if we go back to the original, y minus x equals -2. So if it's in this sort of standard form, you want to be very cautious if it's greater than or less than or greater than or equal to or less than or equal to. As in, can I look at this at the beginning and how do I shade? Sometimes it's the opposite of what you think, but if it's in slope-intercept form, like we have here, if it's greater than, it's always above. If it's less than, it's always below the line. Okay. But if it's not in slope-intercept form, you need to be very careful. I would always check with Desmos. Okay. Similar thing, what is the tan? You could pick any point above. So, for instance, I see here's the origin, right? So I can plug in the origin because that is a point above the line. So if I do 0 is greater than 0 minus 2, I get something that is true. So then I would shade above in that area, okay? So you want to think each of these inequalities have a boundary line. We looked at this. So if I look at this, or this, or this, or this, y is greater than x minus 2, y is greater than or equal to, y is less than or, and then y is less than or equal to. All these will have the same boundary line. Okay. These would be a dashed, right? These would be solid. And then where you shade, right? Since it's in point slope form, you would shade below. And then for these, you would shade above, okay? And the book kind of walks you through that. For the first one here, we see that we are shading above. There's a dashed line. And we have equality now, so our boundary line is actually solid, okay? Because that equal to. And then we have one for if it's less than, okay? Just remember, for all these examples, it's in point slope form. If it's in standard form, sometimes it's the opposite of what you would think, so always graph on Desmos first. Okay. So remember, if it's in this format here, which is standard form, right? So the graph of the inequality would be not equal to 0 is either the upper half or the lower half, okay, of the plane. And it's determined by this line here. Okay. And then if b is equal to 0, then you just have this, which would be what? A vertical line, okay? So then it's either, you could always have this as well. If a was 0 also, you might see some examples like that, okay? So this is just the process. You graph your line first, and you want to think either you're going to shade on one line side or the other. So then you have to choose a point that you pick that's not on your line, it's on one side or the other, okay? And then if the point works in your inequality, then that's the side you're going to shade. Okay. So for instance, if we look at this, 3, so we have 2x minus 3y greater than 6, sorry, less than or equal to 6. So let's say I didn't want to use Desmos here, and I just wanted to graph this, okay? So what would the graph be? So you could either do, first, you could do slope-intercept form, if that's what you want to do. Or the second method would be you do the x and the y-intercept. So both of these methods we learned before. Okay. So I'll just do the second method here, the x and y intercepts. So for this problem, the x-intercept is what? So what is the x value and y is 0? So that would be 2x minus 3y equals, not equals 0. What am I doing? If we're going to put a 0 here. Equals 6. And now let's simplify. So 2x minus 0 equals 6. 2x equals 6. So divide by 2. X equals 3. So 3 zeros are x-intercept, so let's mark that. And then now what about your y-intercept? Okay. So when I find the intercepts, if that's the way I want to graph these, okay, to graph my boundary line first, I can just use equal to, because I'm just trying to get what the equation of that boundary line is. Now the inequality part at the beginning here, that'll help me determine which side I shade and if my boundary line is solid or dashed. So let me plug this in. So remember, the y-intercept is when x is 0. What is your y value? So if I plug that in, so I get that 0 minus 3y, 6. So then minus 3y equals 6, divided by minus 3. So y equals minus 2. So I get minus 2 as my y-intercept, so let's plug that in here. And then I am going to make a solid line, because why? Because my original inequality, so solid, because it has equality, okay? It's not less than or greater than, it's less than or equal to, okay? And then I need to think, do I shade on the top half, right? So would I shade up here? Or would I shade down here? Okay. So I could test a point. Typically, in my experience, the easiest is the origin. So if I plug in the origin, since that is not a point on my line, say, okay, so I'm going to pretty much pick this point here to test. If it's true, I would shade the side the point is on. If it's false, I would shade the other side. So our test point is the origin. So let's plug that in. So 2 times 0 minus 3 times 0. Is that less than or equal to 6? That would be 0 is less than or equal to 6. This is true. So then that means I'm going to shade on the side my test point is on. Okay. So one other way to do this problem is, as I said, slope-intercept. So you can look back at your notes how you would graph, turn that standard form to slope-intercept form. So now I want to show you Desmos. So let's say we did all this work for this. You can always check yourself with Desmos. So if I do, so just type as you see it, 2x minus 3y. Then we had less than or equal to, so hit that button, and then 6. And we see that is our equation right there. We have our intercepts here that are nicely marked. Okay. So in the past, a lot of students really like using Desmos, and since you can use it on your projects and your homework, right? So you can try max problem 1 here. So we have another one here graphing this. So this is a horizontal line, right? So it's horizontal line. Okay. And do we have a graph here? Okay, so we have y is greater than 3, or equal to negative 3, right? Oh, not equal to, whoops. Okay, let's take out that equality. Okay, so we have this. So first I need to think, how am I going to handle this? Well, I know this is a horizontal line. So if I was just going to graph this, I go to minus 3 on the y-axis. And then I'm going to put a dashed line because I don't have equality here. Okay, so it's dashed because greater than or less than, okay? And now I need to think, do I shade above or below? Okay, so I'm just going to pick a test point. I'm going to pick the origin here. I plug in the origin. There's no x, so I just plug in the y value as 0. So is 0 greater than -3? Is this true? Yes. So then I'm going to shade above, okay? So you shade where the test point is. So let's see, how would I do this on Desmos? So if I go back to Desmos, I'm going to just look at the first one. If I do y is greater than -3, I see I have this right here. So Desmos is very good about shading very nicely, okay? And in case you're curious, if you're already working on next sections, if you have 2 here, you know, it'll overlap the shading as well, okay? So similar thing for B. If I want to graph 2x less than or equal to 5, you want to think I can't graph 2x, I need 2, so this would be a vertical line here. So I need to solve for x. So divide by 2, divide by 2. Inequality will stay the same because remember, only when you divide by a negative number does the inequality flip. So I get x is less than 5/2. Or you could say x is less than or equal to 2.5. So I go over to 2.5, which is right here. I'm going to make a solid line to go up and down. Remember, why is it solid? Because it has equality. And then am I going to shade to the left or to the right? So I'm going to pick the same test point. Origin works well. So plug in zeros for x and y's. So, and I would technically plug it into the original in case you, that's just usually a standard way to do it. So if I plug it into the original, so 0 is less than or equal to 5. Is this true? Yes. So we shade 0, 0 side. Okay. So I'm going to shade this side here. And it looks like we have one where it's x is less than or equal to 3y. So graphing this could be difficult. One thing to note here, this will go through the origin, okay? So you could think of this as, I need that boundary line, so I'm going to think of it like this. I'm going to solve for y. So I get y equals 1/3 x. So the slope is 1/3. The y-intercept, I don't see anything here. Like I'm not plusing or subtracting anything, so y-intercept 0. So I go through the origin. Then I'm going to go up 1/3 because my positive slope, up 1, right 3. Up 1, right 3. We can get our other points here. And then we're going to make a solid line because it is greater than or equal to, or if you have less than or equal to, solid line for your boundary line. Okay. And now do I do above or below? Well, I can't use the origin now, so I'm going to pick any other point. Any point on the axis should work, so I'm just going to do 0, 3. Okay. So I plug that in. I get 0 is less than or equal to 3 times 3. So 0 is less than or equal to 9. Is this true? Yes. So you shade on the 0, 3 side. Okay. So I'm going to shade up here. Now, I'm just going to go up here in Desmos and type in the original statement, okay, which is this. So let's type that in Desmos, see if we get a similar thing. So if I do x is less than or equal to 3y, we see here I get a nice shaded space above. Okay. So please use Desmos to help double check your shading and so forth. Right. So we have match problems here if you're curious. Now, This part here is about interpreting a graph, okay? So find the equality of the graph. Given this is just kind of, if I have an inequality graph, can you tell me like what the equation was? Okay. So for this one here, right? So you think about it. I am going to have, and it says it wants it in this format, okay? So you could do a few ways here. Typically, in my experience, it's always easier to, you want to figure out what the slope is. So for this particular one, you want to get your equation first, okay? So in this one, it'd be y, and since we are shading below the line, and the line is solid, right? So it'd be this next, less than or equal to y, below line, and solid line, okay? So the below the line part is the less than, the solid line means equal to. If it was just a dashed line, it would just be less than. Right? If it was above, it would be the other pieces. So I need my slope here. So if I think of this graph, remember, rise over run. Okay, so I'm going to go from the left point, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. So it's a negative slope. So the slope here would be negative 6 over 8x. And what's my intercept? My intercept is 6, so plus 6. So now I can kind of simplify this a bit. And if I need to write it in this format, right? Okay, then what do I need to do? So, if we think about it, I need to move the x to the left side. So I'm going to add over 3/4 x. I get 3/4 x plus y is less than or equal to 6. And usually in this case, a, b, and c have to be integers. So I'm going to multiply everything by a 4 to get rid of that fraction there. So this will be 3x. This will be 4y. This will be less than 24. So this is the graph here. Remember, if you want just the boundary line, it's what you have, but you just have equal to. So the boundary line is this. Okay. I don't know if many of the homework problems have this, but in case, if you do have questions, you can always send me an email. There's a match problem here. And then last is this sort of question. Okay. So a concert promoter wants to book a band for a stadium concert. The admissions tickets will cost a few dollars, right? So it says it costs $125 to the stadium playing field and $175 for seats in the stand. The band requires that you have a minimum, okay, of 700,000. Remember, minimum would mean what? That you're either at that value or it's larger than that, right? Kind of like the minimum age to, purchase, like, let's say, alcohol, 21, right? So your age has to be greater than or equal to 21. Okay. So it says how many tickets of each type must be sold to meet the band's guarantee. Okay. Write this answer as an inequality and draw its graph. Okay, so we see here we have a picture here. So what I'm going to do is we're going to talk about a few things. So you'll see here the band sells either tickets for the stadium playing field or in the stands. Okay, so we're going to say that X is the ticket. You could think tickets sold for playing field. And then Y would be the tickets sold for the stadium seats. Okay. So every ticket you sell, what's going to be the price, right? So if I sell playing field, every playing field is $125. So 125 times X will give me how much revenue, right? How much money I bring in from sales. But then I'm also selling this other type of ticket. And since we think of sales as everything together, I'm going to add to that 175Y. Right? And then what am I hoping the sales to be? I said I want it to be a minimum. So then this has to be greater than or equal to $700,000. Okay. And you could modify this a bit. If you want to reduce it, you'll notice that I can make this a little simpler. I can divide everything by 25. Yeah, so you could divide by common factor if you want of 25. So this would be 5x plus 7y is greater than or equal to 28,000. Right? And you could use this to make your graph. Okay. So the few things you do here, you could always use Desmos. If you want to use Desmos to make your graph, you can. You can also do the intercepts if you'd like. Okay. So let's just key this in on Desmos and see what we get. So 5x plus 7y is greater than 28,000. So we have 5x plus 7y is greater than or equal to 28,000. So we don't see it here, so we need to keep zooming out on your Desmos, and eventually at some point you'll see it. It tells us our two intercepts, 0, 4,000, and 5,600, 0. And we shade above. Why is that? Because remember, the band wants a minimum of this amount. So typically that means they need to sell quite a bit of tickets, right? So you can kind of see intuitively it has to kind of already be above. Okay. So any point up here would work. So I could say, how much should the band sell? I could say 5,000 of each, right? Because 5,000 is right up here. Okay. That could be a point, right? So when it wants you to know, if it wants to ask you, like, how many tickets of each type must be sold, you'll see that if we look at the other answer, it just says that, how many should be sold is going to be whatever is in that shaded area. That's all applicable answers. So I hope you like this video. Make sure you can use Desmos to do your shading. In the next section, we will be shading a few lines at the same time and looking at, corner points. So if you do have any questions on your, just send me an email. Thanks again.